So let's walk through these. Now be careful with the definition mutually exclusive. Mutually means together, but excluding means nothing together. They're excluded from each other. So two events are mutually exclusive if they have no common outcomes. Think of your Venn diagram. Think of them being separated, nothing in common. Those are mutually exclusive. Not mutually exclusive, they overlap. Presidential candidates have lost their popular vote and won the election. This is an overlap. They're looking at two separate things. Losing their popular vote, winning the election. Okay? Movies that are rated R and rated PG-13 cannot happen at the same time. So those are mutually exclusive. Number 9, an event being a female worker and randomly selecting a worker with a college degree. This can happen. If you can save yourself, can I get a worker with a college degree that is also a female? Then they are not mutually exclusive. Number 11, event A, select a person who is a Republican and randomly select a person who is a Democrat. Well, technically, they cannot be the same. They cannot be registered for two different parties. Yes. They cannot be registered for two different parties. So technically, this is mutually exclusive. I don't always like that one because, like, some people have Republican views and Democratic views, differences that they like, but they're always registered as one. And a lot of you probably haven't registered to vote yet. So that's always a little bit different when you do that. You probably will do it in your government class, right? If you're turning 18, you'll do it in your government class. Okay, a math conference has an attendance of 4,950 people. Of these, 2,100 are college professors and 2,575 are females. So picture your Venn diagram. Of the college professors, 960 are females. This is the and condition. This is where I'm a college professor, I'm a female. This is this part right in here. This is where they overlap. So I find it easier to visualize with the Venn diagram. If you have a hard time, go to your Venn diagram. Find the probability that you select one at random, a person at random, and that they are a female or a college professor. So you're going to take the female or the college professor. Get used to writing your probability statement. This is the one where you have to subtract out what's in common. So we take the probability of a college professor plus the probability of a female, and we subtract out the and part. Well, I'm just going to say and in here. So we're going to subtract out the and part because we counted them in both sections. And this is what you end up with. And flip it to a decimal, make your life easy. If you want to reduce your fraction, that's fine. Keep your denominators the same while you're adding and comparing these things. Yes? Technically, all probabilities should be reduced at the end to either a decimal or a fraction. But like I say that, and I say in here, we can leave them like this just because it's easier to compare. Like when you start comparing, unless you put them in a decimal and you've changed your denominators, you're going to have to find the common denominator all over again. I like the 3 decimals because then I don't care about what my denominator is anymore. If what my reducing is, I'm done. I get 3 decimals out of this. And if I look at this and I look at this probability, that to me is a little hard to visualize. Well, the probability says that I'll select a female or a college professor is 3,725 out of 4,950. That doesn't really make as much sense as 75% chance that I will select someone who is a female or a college professor. I like the percentage part of it better. That's just, I think it's easier to understand that part. But whatever you see in here is good. You can leave yours not reduced because if you're going to compare them, you're going to need that. This one was kind of cool. They gave you the probability of producing a carton with a puncture hole in it as being 5%, 0.05. they gave you the probability of producing a carton with a smashed corner as 8%, 0.08, and they gave you the probability of both happening at the same time, that you produced a carton that had both a puncture and a smashed corner. That was 0.004, a little less than 1%, about a 0.5%. Now, your mutually exclusive says if they had nothing in common, we would add them. But here's what they have in common. This happened at the same time. So you're going to do your probability of a puncture or your probability of a smashed corner, and you're going to have to minus the one that they had in between them. It was kind of nice because they gave you just decimals. There's nothing to really to think about. So add those two and subtract the ones they have in common. Good? Okay, the add's not so bad as long as you just pay attention to where your overlap is. Again, when you're rolling die, write it out. It's so much easier to spot if you roll the die and you write it out. Rolling a 5, there's my 5, or a number greater than 3. So my 5 has the X on it from the first part. This is my first event. And then these 3 are from my second event. I can count right from here. 1, 2, 3. 3 over 6. If I do this separately, I realize this says 4 over 6 because I counted the 5 twice. So subtract out your 1 over 6. Probability of a number less than 4. There's 3 numbers less than 4. Or an even, there's 3 evens. This guy I counted twice. Okay. Rolling a 2 or an odd number. Okay, rolling a 2, this one, or an odd number. Are these mutually exclusive or do they have an overlap? Mutually exclusive, there's no overlap in this, so I just add them together. And your probabilities, these are the chances of these happening. I think if you go to a decimal and you look at it as a percent, it makes far more sense than looking at it just as a fraction. Okay. Randomly selecting someone who is 5 years or younger. Under 5 years, 5 years or younger. Yeah, I guess you had to look at your chart to do that. So, since they're set up in all, I know you're about ready to go. Since they're set up in all different ways, that one has nothing else in common with anybody else, just go for that percent. Tomorrow we'll finish going through this and we'll start your rock, paper, scissors lab.